Hello to my second block physical science class. As you guys have probably figured out, I am not here again today. It's Monday. I'm recording this on Sunday, but it's Valentine's Day. I took last Friday off to take Simeon to the doctor, and the night before, I actually started to get kind of sick myself, and I went to urgent care, and I think I have a quick case of influenza. So I got meds, and I'm getting better, but I'm probably still not quite ready to be back at school. So I didn't want us to waste a whole day, so I made a quick lecture here, and I appreciate you guys staying on the ball. The sub on Friday, I'm not really sure who it was. I didn't recognize her name. She wrote that you guys were by far and away the most on-task class of my whole day, and you guys did a great job. So thank you very much, and for all of you, including you, Natalia and Anna, I know you've been haters. There will probably be some snacks involved when I come back on Tuesday, maybe of the muffin variety if we do well. So, getting into what we need to go through for today, we've been learning about the atom. We've also started the periodic table. You guys should get out your periodic tables quick. We're going to write down some notes here. These couple things I go through, you can just put on the back of your periodic table, and those can be your notes. So it's really, really important. I don't know who my sub is yet. They can pause it if you guys need them to. But when we look at the periodic table, we care about the vertical columns and the horizontal rows. Okay, but they are much more than that. We know, and I've mentioned that the periodic table is a huge cheat code of information for us. And we're not just ever going to call them columns. They're much, much more than that. When we talk about the columns, the names that we'll use as a group will be that they are families. I always tell classes, Augie Bodie, be quiet. At my mom's house when we were growing up, she had all of us kids' pictures on the wall going down, and you could tell we all looked kind of alike because we were from the same family. That's kind of how the periodic table works too. You guys saw on Thursday when I was there last that we watched a video of everything in the first family exploding when we put it in water. They don't necessarily look alike. I mean, they kind of do, but they do act alike. We also call them groups. So the first column we call group 1. The last column we call group 18. The horizontal ones, we will call them rows, but more often we'll call them periods, and that's where we get the name periodic table. I always tell kids, think about you write a sentence at the end of a horizontal, or you put a period at the end of a horizontal sentence, and that's what we'll call it. And really, the word period actually has to do with patterns and trends. And as you guys have started to pick up, we know that there's a lot of patterns and trends in that periodic table. So feel free to pause if we need to, but you do need to know these words and what we actually call them. Otherwise, let's keep going. So when we look at our periodic table, and again, here's a little example. This would be called group 2 because it's up and down. It'd also be a family because it's that vertical column. So this would be group 2, and all of these, just like all the first column did in that bathtub, all of these things are going to react in similar ways, and they're all also going to look alike. They're going to have similar properties like boiling point and stuff like that. This shows you an example of a period. So we have a 2 written there, and this would be like an example of the second row or the second period. What we'll start to do when we get to quizzes and stuff is I'll ask you guys, what's the name of the third period in the alkali metal family? And soon you'll know that the third period is the third row, and the alkali metal would be sodium. So we'll have to do a lot of practice there, but we'll get there in due time. Carrying on though, what you guys are going to do today is start to explore some of these families more specifically. I've already alluded to it a little bit, but that Brainiac video we watched potassium get dropped in water, and cesium get dropped in water, and rubidium get dropped in water. And all of those things in the first family all exploded when we put them in water. And the reason is because when we draw out those Bohr models, all of those things have the same exact number of valence electrons, and that's that electron in their outermost shell. Now, obviously, they're different in terms of how many rings they have, but it is very important that they all have one valence electron in that first row, okay? I think I said it the other day, but everything in group 17 has 7 valence electrons, and everything in group 14 has 4 valence electrons. And that is why they act in similar ways. It's not because they're in the same column, it's because they have the same number of valence electrons, and that's what makes them act in similar ways. Going back to my dorky Power Rangers example, we know that if a random kid in town had 6 Power Rangers and another kid across town had 6 Power Rangers, they'd both probably work about the same to try to get 2 more, and that's what we mean by families. So, since some of those families are so special and different from other families, we give them special names, and that's what you guys are going to do today. So, for instance, group 1, everybody, you are allowed to call group 1, but we more efficiently usually call those the alkali metals. That makes sense because they're on the left side of the periodic table. And like we've talked about, hopefully on Thursday last week, you put the +1 here. All of these things want to lose 1 electron to become +1. And everything in this first one we call an alkali metal. That's the name of the group. So if I asked you what's the name of the alkali metal in the 4th period, you'd go in the first column, you'd go to the 4th row, and you'd tell me that that's potassium. Now, what you'll end up doing today is looking up some of their properties, and you can just write these on the back of your periodic table, but all the alkali metals, everything in group 1 in that first column, they all want to be +1. That means they want to lose their 1 valence electron, and if I lose a negative, it makes me positive. They are all very reactive metals. If you get on Google and look this stuff up like you will, that's the first thing you'll see. And like our video showed, those are all very reactive in water because they want to lose that 1 electron. They're all very soft metals. Usually you guys think about metals as being very hard, but they can easily be cut with a knife, and they have very low densities. They're not super heavy. Okay, so with that being said, just reviewing here, hopefully if you did not last week, make sure you get this down, but everything in group 1 wants to be +1. Everything in group 2 wants to be +2. We skip a lot of these middle ones. They act kind of weird, and you can see how it kind of sits lower than everything else. And then we have our -10 trend here. So group 13 wants to be +3. Group 14 special. They can either lose or gain 4, which kind of makes them a middle row. And then over here we have like nitrogen and all of these that have 5 valence electrons, so they want to gain 3. Everything in oxygen's family wants to gain 2, and everything in fluorine's family wants to gain 1. We didn't really talk about why there's nothing above 18 yet, but you'll learn about that today, and hopefully you can kind of put those 2 and 2s together. So, last little bit here. We will not really worry too much right now as a class about this middle block. You can go right that in the middle they are called transition metals. Maybe pause it if we need to, whoever my sub is, but we call them transition metals, guys, because all of these metals in the middle, they don't always have the same charge. They usually have different charges. They can be +1 or +2 or +3, whereas everything else always has the same charge, and that's what makes them special. So for right now, you just need to know that they are called transition metals, and that really will probably be good enough for now. Okay, so in hindsight, the rest of today, you're going to do the following. You're going to review your elements because you have element quiz 3 later. Okay, I think I will leave a short bell ringer for you, and hopefully you went through that already. Then you're going to work on the rest of the family names and their properties. So you guys are going to go look up on the internet, on your Chromebooks, group 2, group 13, group 14, group 15, group 16, group 17, and group 18. And we don't need a ton. I just want to know what are their names mean, what do we call that family, and just what are some of their general properties. We don't need to get super specific, but you need to know how different group 17 is than group 2 because they are very, very different. When you get done with that and those notes, you can grab the periodic table worksheet from the sub, and there's some coloring to do on there and some questions to answer. The colored pencils are in the back in the tan bin by the fume hood. At 10:40, you guys will take element quiz 3. I'll leave the key if the sub wants to grade that, if you guys want to grade it, but otherwise I can grade it too. And with whatever time you guys have left, you should just work on the rest of your periodic table notes. I plan on being back Tuesday, but you guys can do all this on your own today and be kind of inquiry learners and look some of this up on your own. It's very basic info that you guys should understand. I really appreciate you guys being rock stars and being productive. You guys have been awesome, and I know I can have high expectations of you. So get that stuff done. If anyone's been gone a bunch, get them caught up as best as you can and keep practicing those Bohr models. Otherwise, I'll be back Tuesday, and then we'll have a short little Atom quiz Wednesday, and you guys have school off Thursday and Friday. So thanks for being rock stars. I will see all you guys hopefully back on Tuesday if I'm feeling better. Take care of yourselves. Be productive. Thanks for all your work. Bye.